This is just me redoing the problems and explaining them. For the first one, this one is pretty simple. There's two ways to do it. Yes. And actually, I'm gonna do it the way that you did in the first time because I actually like it better. Um, but basically, you factor out the x plus 2. You can factor out x plus 2 squared, and then only one x plus x minus 3. Be careful with the parentheses, but x minus 3 minus x plus 2, well, I'm just going to write the 2 in front, x plus 2 for organization purposes, and then you do x minus 3 to the power 4. I'm going to cancel out in a different color. I'm going to cancel out this one. And all I have left is x plus 2 squared times, I'm just going to distribute them right now. 3x minus 9 minus 2x minus 4. I distributed them right now, x minus 3 to the third. Now what's left is x plus 2 squared, and then I have 1x and I have my 113. So this is your final answer. And then that's honestly all you can do with this one. And yeah. Okay. For the next one, this one is pretty much the same thing. You want to um you want to get rid of the denominator basically. And to do that, I would first probably multiply both sides, or not both sides, but the top and bottom by 7 minus 3x times 7 minus 3x. So you're left with 7 minus 3x. Since you multiply them to each term, so I distribute it to this. I distribute it kind of like this. To this term I have one, and then this term I have one. So, and this term just cancels out. So you have 7 minus 3x. You're just adding exponents, so it's 3 over 2 plus 3 over 2x, 7 minus 3x, and then you're adding exponents, it's 1/2. So that's good. I think I did it a different way today, but I think this one is better. Factoring out, you can always factor out the least exponent, the lesser of 2, so I'm just gonna write that in red, but you factor that out, 7 minus 3x plus 3 over 2x, like that. Let me just double check my work. 7 3 over 2 plus 3 over 2x, 7 minus 3x to the power of 1/2, because I multiplied 1, added. Yeah. So, and then all that's left to do is simplify the inside of this second equation. So it's 7 minus 3x, which is also 6 over 2x plus 3 over 2x. So I'll just write 6, 3 over 2x plus 7. And then 7 minus 3x minus 3 over 2x plus 7. This is your final answer. You could write it like this. plus 7 plus 7 minus 3x. It usually goes like the degrees, so this is technically x to the 0, but since this is x, or yeah, actually this, you would do it like this, my bad, plus 7. Because this is a degree to the 1/2, this is 1/2, this is 0, and then this is just 1, you would put it in order of degree. But that's the second question. For the third one, you have to um, multiply all by the common denominator. 4x to the fourth minus 16x squared plus 4 equals 0. And so I multiply x to the fourth times all of them equals 0. So it's 4 minus 16x squared plus 4x squared, my bad, x to the fourth equals 0. Put that in order. X squared plus 4 equals 0. And then factor out 1, 4 plus 1 equals 0. And this one, since you can't really factor, you have to do quadratic formula, plus or minus b squared minus 4ac. I always write it out so I make sure I'm plugging in the right numbers. Negative, so it'd be positive 4 plus or minus, I'm just gonna do the 4 squared right now, minus 4 times 1 times 1. So I'm just not gonna write the 1 because it's just multiplying, times 1 because the a value is just the 1. So 4 plus or minus 12 over 2. I think, oh, okay. I think I made a mistake in the first time, but since this is negative 4 and negative b, yeah, then the first time I think I made a mistake with this one, but it's positive 4, not negative 4. So then you can factor out 4 plus or minus 2 root 3 over 2. So you factor it out and then you cancel it. So this is equal to 2 times 2 plus or minus root 3 over 2, cancel it. 2 plus or minus root 3. And then you get then you get 2 plus or minus root 3. And this was the form I was factoring out originally. Equals 0, 4, you do plus 2. I'm going to write it in a different color to mean that it's all one term. Plus 2 plus root 3 plus 2 minus root 3. I'm saying that it's the same except for this. It's just the plus and minus. So for this individual equation, I did 2 plus minus root 3 equals 0. For this one, I did x squared plus 2 minus root 3 also equals to 0. And basically, my x's will equal to plus or minus square root of 2 plus root 3. And then it's 6 minus negative, or plus or minus 2 minus root 3. The good thing about the x squared is if you square either of these, it's the same answer, so you only really have to plug in each twice. I mean, one time each. One time, one time. I'll show you what I mean by that. I'm plugging it into the original equation to find the extraneous solutions. 4 to the power of I'm just going to plug in the positive version of both, to the 4th minus 16, 2 plus 3. I have to be careful at what I don't, what I add these, because the numbers are so complicated, but oops, 2 minus root 3 squared plus 4 equals 0. Okay, so basically to do this, I think the easier way is to square it first. So if I square it, I get 4, and I'm just going to remove one square, so I still have one squared left. I square, it's 2 plus root 3 when we square. And then to square this, you kind of have to FOIL it out. So you do 2 plus root 3, 2 plus root 3, which is, I'm just going to move this actually. Move this a little more down, but you get 4 plus 2 root 3 plus 3 over 4. So I'm just gonna remove this part off over here. Okay. And then the same thing, minus 16, 2 plus root 3, because I just square it, plus 4. And then um to be honest, there's not a way to solve this one. Equals 0. Um, I'm pretty sure though that these are solutions. But basically the reason why I have stopped solving it is because you can't really evaluate this without a calculator. I could only do as much as estimating the value, which is a little hard to do if you're saying that this has to equal to this, all added up has to equal to 0, but it's a pretty safe bet. If I look up the answer, it does equal to 0. So yeah, basically, then it has 4 solutions. That's what that means. But it's a pretty safe bet to say that. Also because I didn't simplify out the equation that much. Okay, for this one, it is just, I'm multiplying all of this whole thing by square root of 11 minus x squared. And so basically you get 11 minus x squared minus 2 equals 11 minus x squared. I squared the whole both equations. Before doing that, I'll just solve equals plus 9. I just solve for that. So basically you get x squared, or x to the fourth, my bad, x to the fourth plus 18x squared plus 81 equals to 11 minus x squared, because I just squared it to get rid of the square root. You move everything to one side, so I get oh, this is supposed to be negative, my bad. Negative 17x squared plus 70 equals 0. This one is easy to factor because you can just look at it and think negative 7, negative 10. So x squared minus 7, and then when that equals to 0, just one of them has to be equal to 0 in that moment. So you look for a solution. So x squared equals 7, x equals plus or minus root 7. In this one, it's x squared equals 10, x equals plus or minus root 10. I just plug in, I have to plug it in back to the original equation. So, minus 2, I'm just going to plug it in. But since we already know the results, I'll just say, and I'm just doing the squared automatically, but 2, 11 minus 10 equals 1. Basically, we end up saying that 1 minus 2 is not equal to 1, so 10 is not a solution. So 10 not solution. For 7 though, I know that it is a solution because I already plugged it in, but I'll just show you how to plug it in again. You get 11, 7 squared. I'm already plugging in the root 7. I'm canceling it out immediately, so I don't have to write as much. 4 minus 2 over 4 root 4 equals 1. So this is basically saying 2 over 2. Or, my bad, 2 and 2 over 2 is 1. So then it equals to 1. And so is a solution. Okay. Finally, for this one, it's a kind of a two-step cancellation problem. I'm gonna multiply all of the sides by 1 plus x to the power of 2/3, but in this case, I will just do this. 1 plus x negative 2/3 equals 0. I'm just multiplied it immediately. There's not much math you need to do because the bottom, by multiplying it, you get rid of this. You don't have to multiply this because it would cancel out anyways. And then multiplying it by 0 would just mean multiplying anything by 0, and it doesn't really work. And then the next stage is trying to get rid of this kind of hidden denominator that we didn't see before equals 0. And yeah, but this one actually works well because this just turns into a 1 if we multiply this whole thing. 1 plus x over 2/3. This just turns into 1 plus x because 2/3 plus 1/3 is 1 minus x equals 0. So 3 plus 3x minus x equals 0. 3 plus 2x equals 0. So to solve it, 2x equals negative 3, x equals negative 3 over 2. Plugging it in though, that is the more difficult part. But basically, once you get to a certain point, you will realize that the number does not work as a solution because it is simply too complicated to be a solution to equal to 0 at the end. But basically, it just turns into 3 and negative 1/2 over 1/3 minus, minus plus 3 over 2. I just added it. Plus 3 over 2. 1 minus 3 over 2 is minus half, negative 2/3, and then, I keep forgetting. Minus 3 over 2, so it's negative half 2 over 3. When you have 3, negative 1/2, you can, since 1 is pretty much the same either anyway, you can just move the cube root 3 to the bottom, plus 3 over 2. This is a negative, so if I distribute the negative first, I get a negative 2 squared root 3. That's what it's saying. Equals 0 over 1/2, negative 1/2, 3 squared. So I can keep simplifying, but I'm getting to a point where I soon realize that this top does not match each other, so that it's not possible for it to be 0. Yeah, that's basically my rationale behind it. So this is not a solution. And I also double checked. I looked up these problems online just now to double check the solutions. There is, for the first one, or the first complicated one, these ones on the internet says that they are equations. So I'm pretty sure at some point the numbers start simplifying down. Or if you plug it into a calculator, it might equal 0 at the end. But yeah, that is it.